Whereas which of the following is true? And this is going to be a question that is for our semiconductors. So first we were told, or we're asked, silicon has 5 electrons in its outermost shell. So with doped semiconductors, or donors, they have 5 electrons. So that means that silicon would have to be a donor for 5 electrons. And we don't see that in the notes. We could look that up on Google. And if we were to do so, we would find out that this is going to be false. Next, we have arsenic. It has 4 electrons in its outermost shell. Well, arsenic is a donor. And since it's a donor, that means it has 5 electrons in their outermost shell. And this is because they need to donate an extra electron, right? If we look at our diagram here, we have 4 spots. So a donor would donate 1. And this is going to be false, since it would need to be 5. Now we have boron, has 3 electrons in its outermost shell. So if we scroll down here, we can see that boron here is actually an acceptor. And acceptor atoms have 3 electrons, which is what it tells us that boron has. And we would do the same process to see if phosphates would be a donor or acceptor, and then rule it out based on that. So the answer to this problem and how we would go about finding it is basically if it's an acceptor, it has 3 electrons. If it's a donor, it has 5 electrons. And this is because a donor needs to donate one of its negative electrons, and a acceptor needs to have a hole, a positive. That way our electron from an accepting atom can go inside of it, or an electron accepted from a different atom can go inside of that hole. So basically they trade. We can see that we have 4 negatives here. That's because one of the negatives from this, which is an electron, was replaced here. So they traded the holes for the electrons. So that's how we would go about solving for this.